Yes, hello everyone. Yes, today we will start with the problem on that is Bode plot. Okay. Before starting the problem in Bode plot, we will see that what are the contents in that plot you are having. That we will see. Okay. First step is we have to write the magnitude table. Okay, magnitude table plus equations we have to write. Okay, this is the first step. Okay, and second step is we have to write the phase angle table. Okay, along the phase angle equation. And the third step we are going for the graph. Okay, by using these two values we are drawing the graph. Okay, this is regarding this Bode plot. Okay, first we will start with the one problem. Okay, the problem is like this. Investigate the stability of a negative feedback control system. Investigate the stability of a negative feedback control system whose open loop transfer function is given by here. This is the transfer function they are given. Gh of s is equal to 50 divided by s into 0.5 to s plus 1 into bracket 0.05 to s plus 1. Okay, this is the problem they are given. Okay, here the main thing is we have to see these factors. If this factor is in the form of ts plus 1, then directly we have to start the problem. Suppose if the factor is like this, 110 plus s, then we should not start the problem directly. Then what we have to do, we have to convert this factor as 1 and here coefficient factor. Okay, suppose if you have a factor like this, then what we have to do, we have to write 1 plus 0.1 into s. What I have done here, I have taken the 10 common, then this term will become 1 and this term will become 0.1. Okay, like that you have to see that factor, whether this factor is in the form of ts plus 1. Okay, yes, in our problem the given problem is in the form of ts plus 1. Yes, then we can directly start the problem. Okay, we can directly start the problem. To start the problem, okay, first thing is we have to substitute s is equal to j omega here. S is equal to j omega, and then we will start solving the problem. Okay, first I will substitute s is equal to j omega here. S is equal to j omega. Okay, then what happens? This one, g of h of j omega is equal to g of h of j omega is equal to this 50 as it is divided by I will write this s as j omega into bracket 0.5 into j omega plus 1, okay, into bracket 0.05 into j omega plus 1. Okay, I think this up to this there is no problem at all for you. Okay, next we have to draw the tabular column like this. Okay, this tabular column contains total 4 columns. Okay, first column is factor, second column is corner frequency, this is in radian per second, and the slope contributed by the individual factor, this is the third column, and fourth column has slope of combined magnitude plot in the frequency range. Okay, slope of combined magnitude plot in the frequency range we have to write. Okay, that is the thing we have to write here. See here, to write this factor, what we have to do, we are having some rules. Okay, we have to follow that rules. First thing is we have to write the constant first. Okay, out of, see here, we are having the total factors. This is the 150, and second factor is 1 by s. Third factor is 1 divided by 0.5 into s plus 1. This is the third factor, and fourth factor is 1 divided by 0.05 into s plus 1. Okay, these are the 4 factors we are having. To write the factors in the systematic order, first factor we have to write constant. First factor must be constant. This is the 50 we are having, and so I written the first factor as constant. Second factor must be we have to write second factor as Suppose in your problem, if you have the S term, S 1 by S term, S square term, 1 by S square term, S cube, 1 by S cube, these factor must be second factors in your problem. Okay, first factor is constant and second factor must be you have to select the out of this 6 any one factor, or out of 8 you can take s to the power 4, 1 by s to the power 4. Okay, usually we will have up to 3 only. Okay, out of this 6 factors, if you have any one factor, then you have to write that factor. If suppose that factor is not present, then you can leave that second row. Okay, or don't write the second row. But in our problem, we are having the 1 by s term. We are having the 1 by s term. Hence, we have to write the factor as second factor as 1 divided by s. 1 divided by s. Next, to write the third and fourth factor, we have to use the coefficient of s for the remaining factors, remaining 2 factors. What is the remaining 2 factor we are having? Remaining 2 factors, it is 1 divided by 0.5 into s plus 1. This is the one factor, and the last factor is 1 divided by 0.05 into s plus 1. Okay, what is the coefficient of s here? 0.5. Okay, I will take the coefficient of s, that is I will take omega 1, or omega is equal to reciprocal of that one, that is 1 divided by 0.5, that is equal to how much? 2. Okay, next for this factor, omega 2, that is 1 divided by 0.05, that is comes around 20. Okay, see, this is for the factor 1 divided by 0.5 into s plus 1, and this is the factor that is 0.05, sorry, 0.05 into s plus 1. Okay, now we have to see that which has the least value. We have to select that factor. See, if you consider this factor, okay, corner frequency is 2 here. If you consider this factor, corner frequency is 20. Hence, we have to select which factor has the least factor. That factor we have to write after the 1 by s. Okay, I will write here 1 divided by okay, 1 divided by 0.5 into s plus 1. Okay, and last factor as that is the remaining 1 divided by 0.05 into s plus 1 into s plus 1. If you want, you can write the bracket here, otherwise not necessary. Okay, like this we have to write the first column. Okay, just I will once again repeat the same thing. Okay, because in all the problems we have to write this first column. Okay, first factor must be, before going to the factors, this problem must be in the form of ts plus 1. Problem must be in the form of ts plus 1. Then only you can write the put s is equal to j omega, then g of h of j omega is equal to, you have to write like this. After writing this one, you have to write the factors. To write the factor, first we have to select the constant value. Here our the constant value is 50. Hence I have taken the constant value as 50 here. Next factor must be out of that 6 or 8. You have to select the second factor, that is 1 by s. 1 by s is the second factor. I have taken only from this. Okay. Next, to write the third factor, we have to find out the corner frequency. For this one, coefficient of s is 0.5. Reciprocal of that one, that is 1 divided by 0.5 is 2. And for this term, coefficient of s is 0.05. Reciprocal of that one is, that is 1 divided by 0.05, that is 20. Hence, it has the least corner frequency. Hence, we have to take that factor in the next order. Okay, that factor in the next order. And last factor is, this is the last factor because it has the highest corner frequency. Okay, this is the regarding the to write the first factor. To write the second column, for the constant there is no corner frequency. Always for the constant there is no corner frequency. For 1 by s term, here also there is no corner frequency. For 1 by s term also there is no corner frequency. For this term, okay, I will write here omega 1 is equal to 1 divided by 0.5, 1 divided by 0.5, that is equal to 2 radian per second. 2 radian per second. Okay. And last value as that is omega 2 is equal to 1 divided by 0.05, that is equal to 20 radian per second. Okay. This is regarding the first column and second column. To write the third column, what we have to write? Okay, we have to write the 20 log 50. 20 log 50. Okay, whatever the value will come, just you have to write that value here. That is the 20 log 50. And for this one, we have to write the corner frequency, slope contributed by the individual factor as minus 20 dB per decade. Minus 20 dB per decade. Okay. For the third factor, again see here, if the factor is in the denominator, then we have to write minus. If the factor is in the numerator, then we have to write the plus. Okay. Here we are having the denominator factors, hence I have taken the value as minus 20 dB per decade. Again here also you are having the denominator first order factor. Here again I will write minus 20 dB per decade. 20 dB per decade. And the last factor is also same thing, that is in the denominator first order, hence I will write the value as minus 20 dB per decade. 20 dB per decade. See, to write the last column, what we have to do? We have to write the one line here. We have to write the one line. Draw a straight line. At whatever the value you are coming here, you are getting here, you have to write that value. Draw a straight line at, say, whatever the value you are getting, you have to write that one, and you have to write last at the dB. Okay, this is regarding the first line. Okay, for the second line, what we have to do? Minus 20 dB per decade. Minus 20 dB per decade. Okay, see, whatever the value is there, you have to write the same value here, and you have to write the minus 20 dB per decade. Starts from, okay, in the x-axis we are starting from the 0.1. Okay, hence we have to write the value as 0.1 radian per second to 0.1 radian per second to, what is the second corner frequency? First corner frequency we are having 2 radian per second. 2 radian per second. Okay, this is regarding the fourth column, second line. Okay, to write the next value, that is for this minus 20, we have to add again minus this 20. Okay, minus 20 minus 40 dB per decade. Okay, starts from, okay, that is 2 radian per second to, next, what is the next value we are having? That is 20 radian per second. Okay, and last one is again for this minus 40, again we have to add this minus 20. Okay, then minus 60 dB per decade. Okay, starts from 20 onwards. 20 radian per second onwards. Okay, thank you.